Welcome to the vlog. If you're new here, my name is Chris and I build productivity apps. I usually focus on one productivity app per video, so today we're focusing on Ellie. Quick context, Ellie is a daily planning app. It's basically your to-do list and calendar combined. If you're someone that likes to plan and time box your day, you should go check it out. But that's the app that we're gonna be talking about today. So I use Ellie on a daily basis. I actually can't function without this app, to be honest. But one of the areas that I think can be improved is the calendar functionality of the app. In my opinion, Ellie is primarily a to-do list application and then a calendar second. And because of that, I haven't really put too much time on the calendar side of things, but I do want that to change. As I was looking at the calendar of Ellie, I was thinking, okay, how can I improve this? I started looking at other calendars on the market, like Apple Calendar and Notion Calendar. One thing that stood out to me was these apps are really fast. The minute I open the app, the calendar events load instantly. But when you open up Ellie, the calendar events take like 5 and sometimes even 10 seconds to load. So speed is an area I haven't really looked at. And I thought to myself, this would be a great first step in really improving and getting Ellie to the level of these other calendars. Setting a good foundation, making it really fast in performance. So that's the problem, and that's what I decided to work on in the last week. That's what this video is going to be about. I'm going to take you guys through the speed improvements that I made. I'm going to show you guys some of the stuff I learned. We're going to walk through some code, and this is going to be a little bit more technical than the videos I usually post. So let me know in the comments if you have any feedback on that, and if you guys like it, I'll post more videos like this. So yeah, this is what we're going to be covering today. Okay, so very summarized, the problem is Ellie loads very slowly. A lot of the other calendar apps load very quickly. So the way Ellie works is when you load up the app, I have to go and fetch the calendar events directly from my server every single time. And in some cases, that can take up to like 10 seconds to load the calendar events. But what happens is when someone loads the app, it's just a blank calendar, and then there's like a little spinning icon that shows, hey, we're loading events, which some people don't even realize that that thing is spinning. And then after 5 to 10 seconds, the calendar events load, which obviously is not great. And what's worse is that every time you start moving in the calendar, like if you go to the next week, that's another 5 to 10 seconds to load the next set of calendar events. If you change which calendar you're looking at, that's another 5 to 10 seconds to reload that stuff. It might not seem like a big deal, but I feel like for something like a calendar where you're constantly moving, you're constantly changing calendars, this will start adding up over time, and it does make for a really bad experience. So something I noticed in other apps, so let's take Notion Calendar for example, is that they load instantly. When I'm tabbing between pages or when I'm changing calendars, I notice that they load extremely quickly. So that's the standard that I want to hit for Ellie. I want these calendar events to load near instantly. And that's what I mean when I say I want to improve the performance of the app. Because again, performance can mean 100 different things. It could mean that the app in general is faster. It could mean that certain actions are faster. But in this case, it means that the calendar events load much, much faster. That's the kind of performance that I want to achieve here. Okay, so let's talk about the solution. First thing I did was study how some of the other calendar apps in the market work, because a lot of these calendar apps have teams behind them that have thought really hard on how to optimize performance. So if I don't have to reinvent the wheel, I won't. So the first thing I did was I picked one of the calendar apps to look at and study, and that app was actually Notion Calendar. And the reason I chose Notion Calendar is because if you didn't know, Notion Calendar actually used to be an app called Cron. When Cron first came out, it was known for its blazing fast performance, its really good design, and I'm pretty confident that the team behind it put a lot of thought into the speed of the app. So if anyone did it correctly, it was the Cron team, which is now the Notion Calendar team. The second reason that I chose to study them is they actually have a web version. It's pretty easy to take it apart and look under the hood. So that's a huge reason that I chose them. A lot of apps actually leverage this thing called IndexDB, which is basically like a local database that lives in your browser. It's very lightweight though, so you can't really store complex data here. It's very commonly used for stuff like caching, and which in this case, that's what this is. We're just kind of caching calendar events so they could be pulled up way faster. And after digging through Notion Calendar, it does look like that's what they're using. In Chrome, you go to this application tab and you can actually see IndexDB here. You can do this for any web app and you can see what is being stored on your browser. They're basically storing a copy of all the calendar events and some other data in IndexDB. I decided to also test this because whenever I cleared IndexDB and reloaded the app, it didn't load instantly. And then when IndexDB is full of data, it does load instantly. So I have some pretty high confidence that this is how they're actually storing things locally and caching it. So after looking at IndexDB and then a couple of other solutions like local storage or SQLite, this is probably the technology I should use to solve this problem. That was the research phase. Once I figured this out and I was like, okay, this is the right path, then I started working on actually implementing the solution. Fair warning, I'm not an expert in any way on this stuff. I actually just learned IndexDB basically in the last week. Absolutely feel free to correct me in the comments section. So a little context on the technology. Ellie's a React app. Even the desktop version is technically a React app. It's just wrapped with something called Electron. The underlying technology is React. And I use this thing called Redux for state management. I'm not going to try to explain Redux here, but basically just know that it manages the state of my application. This is basically how components can pull data and talk to each other. So my calendar can talk to my list, can talk to my Kanban. they're all talking and it's all synced through Redux. Whenever I want to pull calendar events, I have this function in Redux that pulls events from my server. It's made up of a bunch of sub-functions to fetch specific calendars from the server. So there's a Google one, an Outlook one, and an Apple one. Let's take a look at the Google one. All it's doing is literally calling my server, getting the events, and then returning it. This looks kind of complex, but it is very simple. Some of this is just the syntax for Redux. That's just how you write it. At the heart, all it's doing is pulling from the server and then storing it in Redux so that my application can use it. So my high-level plan to do the caching is let's pull from the cache first while we're waiting for the server to return stuff. Then the second part of this is when the server returns the fresh data, let's go use that fresh data and let's also update IndexDB with that fresh data. It's a two-step process. Let's load from the cache. When the data comes in, let's go update the cache. Very, very simple. I'm sure there's a better way to do this. This is basically the structure that I decided to follow. The hard part was actually the second part, which was when we get fresh data from the server, let's go update IndexDB with that fresh data. And it sounds really simple. When you get fresh data, go update IndexDB with that data. But here were two things that I ran into with this. When I'm pulling data from my server, it's usually filtered. I don't just pull all calendar events from Google because A, Google won't allow that, but that's also very expensive to do. There could be tens of thousands of calendar events. So you usually have a filter on this, and it's usually a time-based filter. So it's like, just give me calendar events between, Monday through next Monday. Or it's filtered on what calendar I'm actively looking at. So if I'm looking at my calendar and then maybe I'm looking at someone else's calendar, I'm then filtering on both of those calendars and the time range. There's a lot of filtering going on when I'm pulling from my server. So if I decided to just override IndexDB with the data coming in, then the issue is I might accidentally wipe some data that's not included in that filter. To show you an example, let's say that I have a month's worth of data loaded in IndexDB, and then I decide to pull from my server just this week's worth of data. When I pull that week's worth of data and then override IndexDB, I basically wipe potentially weeks worth of data from the last 3 weeks. I needed to find a solution that will let me just update that portion of IndexDB. This actually took a lot of trial and error to figure out. The solution seems so simple now in hindsight, but it did take me some time to get here. So the first thing I do was I actually run the same filter on IndexDB. So I pull it based on a specific time range or specific calendars, and it'll return like 15 calendar events. Then I pull from my server, which again has the same filters, and it loads 15 calendar events. So now I have events from IndexDB with these given filters, and I have events from my server for these given filters. And then I iterate through this list of events. Then I do a couple checks. So if the event is in IndexDB, but it's not in the server, that means that it was probably deleted. So I go ahead and delete that from IndexDB. And if it does exist in IndexDB, then I update it with the version that just came from the server. So now it's up to date. So that solves our problem. And then we get to keep all the old data. So if you have months worth of data loaded or a bunch of other calendars loaded, those remain untouched. Only the relevant portion is updated. So again, this sounds really simple, but it took me a long time to figure out. I tested like 3 or 4 other things before I came to this really simple solution. And so far it's working. So I don't see any problems with this, but if you notice anything, definitely let me know. And so again, this is the code that goes and updates and refreshes IndexDB with that portion of events that we just pulled from the server. And I had to rewrite this 2 other times because I needed to do it for Outlook and I needed to do it for Apple. But basically they follow the same type of structure. And here's the portion of the code where I actually fetch from IndexDB before we hit the server. And again, it had to be duplicated 3 times because Outlook and Apple. So the final result is we now pull from IndexDB while we're waiting for the server to respond with the fresh data. And so the result is near instant loading if the event has been loaded before. If the event has never been loaded before, there is still that waiting period, but for events that have been loaded, it's near instant. If you start moving between the weeks, and again, it's stuff that you've already seen, so if you start moving into the past, these events should load instantly. And this concept of loading from the cache and then the network and storing in IndexDB, this can be used for basically everything. So I actually decided to use it to load the actual calendars themselves. So when you click this button, there's a drop down of all your available calendars. I had to pull the fresh data from the network every single time. So that took like 2 to 3 seconds to load. But now we're storing everything in IndexDB. You don't have to wait anymore. It loads instantly. And then again, we get fresh data and then we update it. So these little improvements to speed in certain areas of the app, I think they do actually add up. And you can apply this technique to everywhere. So I plan on doing the same thing for loading the lists on the sidebar. I actually plan on doing it to load Ellie tasks. So all the tasks should be loading instantly. User settings should load instantly. I'm gonna monitor the results of this calendar improvement, and if everything goes well and I didn't miss anything, I'll be adding caching to basically every portion of the app. So let me talk about some of the things I ran into that are interesting to call out. So one of the things that kind of caught me off guard was IndexDB has a versioning schema. I'm coming from the world of Firebase and NoSQL databases where there really is no schema. So for IndexDB, this was slightly more complicated, not too bad, but every time you change the schema, you have to upgrade the version number. So that way it knows, okay, what version are you on? Then you can write an upgrade function, which then will help help you migrate the user's data to the new schema. It was a little annoying at first during development because I was constantly changing the schema, but I got used to it, and in hindsight, it does give me some peace of mind that when I do make changes, I can just migrate users over and have a lot more control over that. If you come from the SQL world or use something like Supabase, probably not new at all, but for me, that was a little bit of an annoyance, and there was a lot of crashing going on because I didn't understand how the schemas worked, so that part got me. Another thing I ran into was I have to be really careful because I kept storing corrupted data. So for example, when I was pulling the calendar accounts from my server actually crashed and returned an error, and I accidentally stored that error message in IndexDB instead of my Outlook calendars, and so the entire application was crashing because of that. That really freaked me out because then I realized, oh man, if I mess this up, it's going to be way harder to debug on users' machines. Basically, the stakes are a little bit higher here now that I'm doing local caching and storing data locally, where if I store corrupted data or something goes wrong, it's just a little harder to correct than usual. To combat this though, I thoroughly tested this thing, and I actually did add a button in the settings where when you click it, it'll completely clear IndexDB. If there's an issue where like somehow it saved corrupted data, they can click the button and just wipe it. So hopefully that'll buy me some time. I also added a little bit more robust error handling. Before, the error messages were super generic and just said something went wrong, please contact support. Now they say that, but they also give a little bit more descriptive of an error message. Whenever someone contacts me, I'll have a little bit higher chance to know, is this an IndexDB problem or is this something else? And then I can troubleshoot a little bit better. So that was something I did to try to make debugging a little bit easier because these bugs will be really challenging when they come up. So that was a second thing that I really ran into. In the process of redoing this, I made a ton of other performance changes. There was another bug, which was like a race condition where when you drag a task, then you move it really quickly, it'll glitch and then hop back to the first place and then correct and go back to where it was. Since I had a chance to kind of go in and relook at this code, which a lot of this was written like a year ago, I had a chance to correct some of these things. So overall, not just the speed performance, there was actually a lot of stability changes that came with the update I released this week. Overall, major improvement for this feature. There's still a lot of things I can improve. Like when I look at Notion Calendar, it opens still near instantly, and mine, although a lot faster, it's not really near instant. I have an idea of how I can improve this stuff, but I've decided this is good enough. I'll save that for later in a future improvements. I plan on also taking the exact same technique and applying it to the iOS app, but instead of IndexDB, I'll probably be using something like Core Data. Most platforms do support something like an IndexDB for caching. So if you have an application, highly recommend checking that out, but I'll be applying it to the iOS app for sure. But yeah, that's the big performance update that I've been working on in the last week. I had a lot of fun learning IndexDB. I think I'll be using this for a lot of features and all my other applications moving forward. So this was really, really fun for me to learn, and I wanted to share this with you guys. So hopefully you guys found this interesting, and if you like this kind of content, definitely check out my Instagram and TikTok. I post almost every other day about building productivity apps, and obviously if you like this content, don't forget to subscribe. But thank you guys so much for watching, and I'll see you guys in the next video.